Okay, geometry scholars, we have a review from Chapter 7 today. Monday is a test, so make sure you're ready to take notes here from Chapter 7. Turn in on Monday. Number 1. In an orchard of apple and peach trees, 3/7 of the trees are peaches. Let's start with that information. 3/7 are peaches. The ratio of peach trees to the total is going to be 3:7. And they want us to know what is the ratio of apple trees to peach trees. Apple trees to peach trees is what we're trying to figure out. Well, if I have a total of 7 over here, and 3 out of every 7 are peaches, I know that 4 out of every 7 are apples, 3 out of every 7 are peaches, so 4 to 3 will be the ratio of apple trees to peach trees. Number 2. Determine whether trapezoid ABCD is similar to trapezoid PQRS and justify your answer. So if polygons are going to be similar, they're going to have corresponding angles that are congruent and corresponding sides that are proportional. They've given us all these sides. Why don't we start with the sides and see if we can test whether these are proportional. 9.6 on the left would have to match up with the 6 on the right if these possibly are proportional. 15.6 on the left would have to match with 9 on the right. And there are many others, but let's just start with these two. Decimals don't make it real easy to reduce the fractions, so let's start with cross products. 9.6 times 9, 86.4. 86.4. Does it equal the product of 6 times 15.6? 93.6. Not so much. Not equal, not proportional. No, these are not similar polygons, similar trapezoids. And the reason? Because corresponding sides were not proportional. So we do not have similar polygons. Number 3, in triangle ABC, and they give us some measures, and another triangle DEFs give us some measures, and we're trying to figure out whether these triangles are similar to each other. Let's do a little sketch of some triangles. Don't have to be to scale. We'll get ourselves a couple of triangles, put letters on them, put the values that they have done, and we will see if we can't figure out if these are similar or not. So ABC, DEF. Let's go to the values. Measure of angle A is 51. Measure of angle, or side AB is 14. Side AC is 20. And triangle DEF, angle D is 51. And DE is 16.8. And DF is 24. Determine whether these are similar. Remember, there are 3 ways to determine whether triangles are similar. We have angle-angle similarity, we have side-angle-side similarity, and we have side-side-side similarity. Either 2 corresponding angles are congruent, or 2 corresponding sides are proportional with the included angle congruent, or all 3 corresponding sides are proportional. Any of those 3 can do it. So it looks like in this case, what we are going to want to check is the side angle side. Will that work? Well, we have our 51 degrees, so let's try our sides here. 14 to 16.8, is that really proportional with 24, 20 to 24? I went left to right, 14 to 6.8, so go left to right, 20 to 24. And again, we'll do cross products, see if we have equal answers. So 14 times 24 gives us 336. And then if we do 16.8 times 20, 336. So that checks out. So are they similar? Yes, they are similar. Does it ask us a reason? Justify your answer. So our justification on the answer of this is side angle side similarity. Side angle side similarity theorem is how we would know those are similar to each other. Number 4. A painting that is 48 inches by 12 inches is reduced to fit on a canvas that is 30 centimeters by 10 centimeters. Find the maximum dimensions of the reduced painting. 48 by 12. So here's our original. We're going to get a painting. Here's our beautiful painting, 48 by 12. We will not try to put any picture on our painting. It's just a nice purple painting. Purple sunset on a purple ocean. Or something like that. All right, 48 by 12. It's supposed to be reduced to fit on a canvas that is 30 centimeters by 10 centimeters. So our 48 maybe is reduced down to 30, and our 12 is maybe reduced down to 10 here. And we are wanting to figure out what is actually the maximum dimensions. Well, let's start with this 30 down here. 48 to 30 is the new value. So we don't know if it actually goes all the way down to 10. What would the 12 reduce to if we had to reduce the 48 down to 30? So I'm just going to call an x down there, and we'll see if we can figure that out. 48x must equal 30 times 12. So if we then divided by 48, we would figure out what x is, that missing dimension. So 30 times 12 divided by 48. $7.5 inches. So if I'm going to reduce that 48 down to 30, we are going to have to reduce the 12 down to 7.5. So our new dimensions, 30 inches by 7.5 inches. Number 5. Find the value of x. All right. So we have a proportion here. We have, let's start with that 2x on what it would correspond to. Now that 2x is the complete side down there at the bottom. So it would correspond to the complete side at the top. 6 plus 4.8 would be 10.8. The 2x would have to correspond to 10.8. It would be proportional to, since we have a couple of similar triangles here, or a triangle where a line has been drawn parallel to one of the sides. We know we've used proportional parts. So 2x, whole thing, compared to 10.8, the whole thing. And that would equal 6.5 on the bottom. And 6.5 on the bottom corresponds with 6 on the top. Those segments. So again, we'll do cross products. 2x times 6 is going to have to equal 10.8 times 6.5. So if I go 2x times 6, we would have 12x equals whatever 10.8 times 6.5 is, and right now it doesn't really matter, because what we're looking for is the x. So if I divide by 12, I can figure out what x is going to be. So let's see, 10.8 times 6.5 divided by our 12, 5.85. X must be 5.85. If you're following along with your calculators, you can either get the answer before I do, or verify my answer, or say, wait a minute, that's not the right number. Well, 5.85 is on this one, thankfully. Number 6. Okay, they tell us triangle ABC is similar to triangle XYZ. Trying to figure out what Y is. So again, if I have similar triangles, I know corresponding parts here, corresponding sides will be proportional. So that side 2y is going to have to correspond with the y plus 3 because of the position it is in. So that must be in proportion with 17.5. Again, I'm going left to right. So 17.5, which would have to correspond with 14. Cross products once again. 2y times that 14 must equal the y plus 3. Put it in parentheses because it's the complete expression, y plus 3, that we're multiplying by 17.5. Okay, so multiplying these together, 2 times 14, that's 28y, equals, need to distribute the 17.5, 17.5y plus, take that 17.5 times 3, should get 52.5. So let's get some like terms together. Subtract the 17.5 from 28, so that would be 11. That would be 10.5. 10.5y, this is taking 28y minus 17.5y. 10.5y equals 52.5. Divide by that 10.5. And we get 5. Y must have a value of 5. Number 7. The ratio of the measures of the sides of a triangle are 2 to 5 to 6. If the length of the longest side is 48, figure out what the perimeter is. All right, so if we know the lengths of the sides are 2 to 5 to 6, and we're trying to find the perimeter, well, we can set up knowing the longest side was supposed to be 48. And we know the longest ratio in what they have given us, the longest number is 6. So we know that 6 must correspond to that 48. So 6 times something, 6x, must be 48, our scale factor. Well, we can divide by 6, and we know that x is going to have to be 8. So now that we know x is 8, we can come back. They have told us 2 to 5 to 6. So 2x plus 5x plus 6x must equal the perimeter of this triangle. And we know what x is. X is 8. 2 times 8 plus 5 times 8 plus 6 times 8. That will give us our perimeter. So 16 and 40 and 48, adding them all together, 104. The perimeter of that figure must be 104, and I guess they didn't give us any inches. Oh, they did, 104 inches. 104 inches. So we did know the unit of that. Number 8. Random triangle appears. So we'll get rid of such triangle. We'll try to get rid of such triangle. There we go. Number 8. Find the measure of angle I. Well, let me get a quick sketch. You have that sketch there that you are looking at. Got a figure that looks something like this. And they have told us, and it's real important, that we have some parallel sides right over there. We have 53 degrees in this corner. We have 45 degrees in that corner. And we're trying to figure out the measure of angle I over here in this corner. Well, we know this angle I is going to be congruent to this angle G up here because those are alternate interior angles. So if I can figure out my measure of angle G, I will know what the measure of angle I is. And we can figure out the angle G because we know in every triangle it adds up to 180. So if we take 180, subtract our 53, subtract our 45, it's a 5 down there, what is left over must be the angle that we are looking for. Subtracting those gives you 82. Measure of angle I must be 82 because it's congruent to angle G. Number 9. Triangle ABC is similar to triangle DEF. They've given us AB and BC and AC. So they have given us the measures of all the sides in the first triangle. Let's get the perimeter in that first triangle. 8 is one side, 13 is the second side, 15 is the third side. So if I added up all my sides, let's see, 28 and 8, 36. 36 is the perimeter of the first one. Then they tell us DF, the last one. DF is 20. That's in my second triangle. And DF, if you look at the order, must go with AC. AC. And AC was 15. Now we can get the scale factor. Now I went the second triangle to the first triangle. You can go to the first to the second. I went the second triangle to the first triangle. Let's reduce that 20 over 15. 5 goes into 20 4 times. 5 goes into 15 3 times. The scale factor between the second to first triangle is 4 to 3. So that scale factor 4 to 3 must equal the ratio of the perimeters. Second to first. Well, the first triangle had a perimeter of 36. I can figure out the perimeter of the second triangle, since the ratio is 4 to 3. Cross products. 3 times P must equal 4 times 36. Divide by our 3. To solve for that P, I'm going to do a little reducing. Don't have to worry about triangles then. 3 goes in, or don't have to worry about calculators. 3 goes into 36 12 times. 4 times 12 is 48. That triangle, that second triangle, must have a perimeter of 48. Doesn't look like they gave us any units, so we will just call it 48. The ratio of the perimeters is the same as the ratio of corresponding sides, or it's the same as the scale factor if we have two similar triangles. So that's the fact we used on that. Number 10. Let's get a picture. I think a picture is probably the easiest to help us do it. The last one I didn't draw a picture. Probably would have been a little clearer to see if I would have drawn a sketch. Triangle ABC. So I'm going to get a triangle ABC. There's my triangle ABC. It says it's similar to triangle JKL. So I've got another triangle. ABC, JKL, AB is 12, BC is 18.4, KL is 6.9, JL is 5.6, not to scale, doesn't matter. Find the scale factor of ABC to JKL. So we want the scale factor going this way. Well, all we need to do is find two corresponding parts. And since I drew it out in the same order, here it is. 18.4 corresponds to 6.9. Now we want to reduce this, but we don't want to have decimals there. So an easy way is to rid ourselves of the decimal. I can multiply the top and bottom by 10, 184 over 69. And that gets rid of our decimals. And now we just need to figure out a number that goes into 184 and 69. Now some of your calculators actually reduce fractions for you. I think the number 23 goes into both of them. You divided them both by 23, 8 to 3, or written this way, 8 to 3. Here's the scale factor. Find the scale factor, we just need two corresponding sides, reduce that. Number 11. Find the value of y. So they give us a nice diagram down here. We've got three parallel lines cut by two transversals. We notice on the bottom that those segments are congruent, so we know the segments on the top have to be congruent. 4y minus 7 is going to have to equal y plus 8. We have a theorem that says if 3 or more parallel lines are cut by 2 transversals, it divides all the segments proportionally. And if the bottom are 1 to 1 or equal, the top are 1 to 1 or equal. So I'm going to subtract y from 4y, that'd be 3y. Going to add 7 to 8, that's 15. Divide by your 3, and we have the value of y. Y must be 5. Page 2. Number 12. Find SR. All right, I'm going to draw a diagram you can mark right on your paper. So we've got a big triangle like that, got an angle coming through. They're showing that these are congruent right up there. We have a 30, a 12. This whole side is 40. Find S to R. S to R is what we are trying to find. Well, I'm going to call X the part that I don't know, or the part that I'm trying to find. Well, if this whole bottom side is 40, and S to R is X, I know this must be 40 minus X, whatever that is. And we know an angle bisector in a triangle will divide that third side into parts proportional to the original sides. So I know that 30 over 40 minus x must equal 12 over x. And we'll do cross products. 30 times x must equal 40 minus x, in parentheses, the whole thing is being multiplied by the 12. 30x must equal, distribute that 12, so it would be 480 minus 12x. I'm going to add 12x to 30x. 42x equals 480. Now we can divide by 42. And what do we get? 11.43. Let me do that again. 480 divided by 42. 11.43 if we round it. So that one didn't come out even. We'll take it to a couple of places. Remember, it's better to take it to more decimal places than to round it too much. So we'll call it 11.43. Number 13. Now, there's some directions here. They say for questions 13 and 14, refer to triangle FGH, which is similar to triangle JKL. They're wanting us on 13 to find the value of x, and x is an altitude. We know that corresponding altitudes are proportional. So if I take that 12 on the left, it corresponds to 7.5 on the right. That must be proportional with x on the left, corresponding with 4.5 on the right. And cross products. 7.5 times x must equal 12 times 4.5. Dividing by 7.5 to isolate the x. X equals, see if you can beat me to it and get the right answer. Maybe somebody already yelled out that it's 7.2, and the person who said that was right. And the one who said something else, not so much. 14. Move over to this unused space. 14. Find the ratio of the perimeter of FGH, the big one on the left, to the perimeter of JKH, the one on the right. Well, we know that the ratio of the perimeters are the same as the scale factor to them. And we know that the 12 corresponds to 7.5, so we can start there. 12 corresponds to 7.5. That is going to be the ratio of the small one to the large one. So we are just going to have to figure out a perimeter value, aren't we? If I've been thinking right, we don't need a perimeter value. We know the ratio of corresponding sides, or the scale factor, is the same as the ratio of the perimeters, and they ask us for the ratio of the perimeters, not any perimeter. So we just need to take this 12 over 7.5 and figure out what that scale factor is. You need to get rid of that decimal. I'm going to multiply by 10 again. 120 over 75. Now I just need to reduce this 120 over 75. And I believe 15 goes into both of those. Let's see. 120 divided by 15 is 8. 75 divided by 15 is 5. There it is. 8 to 5 is the ratio of the perimeters, because the ratio of the perimeters will be the same as the ratio of any two sides, or the scale factor. 15. Find AD, the length AD, so that DE, segment DE, is parallel to segment AB. Okay, well, we had a theorem. It was the converse of a theorem. It says if we have a line that divides the sides of a triangle proportionally, then that line is parallel to the third side in the triangle. So we just need to make sure we have some proportional segments here. I'm going to go 2x minus 4, and you can pick what you want to match it with. I'm going to go across and go 3x. So if I go across left to right, I need to go across left to right on the bottom. 5x would then correspond with 8x. Again, you can go left to right, you can go top to bottom, you can go bottom to top, right to left. Just don't go diagonally when you set up a proportion. All right, cross products. See if we can figure out what this x is. 2x minus 4, that complete sum, times the 8x, must equal the 3x times 5x. So distributing my 8x times 2x, 16x squared, minus 32x equals 3x times 5x, 15x squared. Let's subtract that 15x squared. Minus 15x squared from 16x squared, that's 1x squared. Minus 32x equals 0 if I subtracted that 15x. All right, factoring. I can factor out an x. X is common in these two terms, so I'm going to factor out an x. X minus 32 is left. And we still are trying to figure out what value of x make this equal 0. Well, there are two places where I can figure out a value for x. Either this first one equals 0, well, x is 0. Or the second one needs to make a 0. Well, 32 minus 32 is 0, so x can either be 0 or 32. Now, if we look back at our picture, can x be 0? And I hope I heard a no. X cannot be 0, because I can't have a 0 length, so I know x can be 32. Now, their question wasn't, what is x? Now, that's useful. Their question was, find a to d. And a to d is this 2x minus 4. So if x is 32, 2 times 32 minus 4 is going to be our length from a to d. Well, 2 times 32 is 64, minus 4 is 60. From a to d, we must have a length of 60 in order to make it true. All right, number 16 is a question from something that we did not do, so you get to skip number 16 and move on to number 17. When a 15-foot tall climbing wall casts a 20-foot shadow, let me start there. 15-foot wall casts a 20-foot shadow. So there's my wall, 15 feet. And here's my shadow, 20 feet. A building casts a 32-foot shadow. So we have some other building, same time, it casts a 32-foot shadow. We're supposed to figure out how tall that building is. Now we know the sun is at the same angle for both of these, so here's the sun shining down, and the sun, whatever that angle is, this angle is right over here. It's in the same place in the sky. So we know we have two similar triangles. Building stands straight, wall stands straight, angle-angle similarity. So let's figure it out. I know the 15 would correspond with the height of the building, and I know the 20 shadow must correspond with the 32 shadow of the building. Cross products. 20h equals 15 times 32. Divide by our 20. Get your calculators running. Beat me to the answer. 24. It must be a 24-foot tall building. 2 stories tall, if I was going to guess. 18. If triangle ABC is similar to triangle EFG, and BD and FH are medians. So look at the diagram there. BD is a median, FH is a median. We want to figure out what B to D is. Well, if we have similar triangles, we know that corresponding medians are proportional to the sides. So we have 15 1/4, or 15.25, might be easier to write that. 15 1/4, 15.25. That must correspond, or 5 1/4, sorry, not 15, 5 1/4. That must correspond with 7. It must be proportional with the 2x minus 5. That median corresponds to the x plus 5 median. So again, cross products. 5.25 times our x plus 5, the whole thing needs to be in parentheses, equals the 7 times the 2x minus 5, and again, 2x minus 5 in parentheses. So we're multiplying 7 times that complete thing. All right, need to distribute, starting on the left. 5.25x plus 26.25, if I did that right, equals 14x minus 35. All we're doing there is distributing. Going to get like terms together. I'm going to subtract the 5 1/4 from that 14. 8 should do this in my head. 5 1/4 from that 14. 8.75 x. I'm going to add the 35 to this 26.25. So that would be 61.25. Need to divide by 8.75 to try to figure out the x. Let's see here. X is 7. Now, not our answer. Have to be careful. X is 7. Question asks, find B to D. So B to D, 2x minus 5. 2 times 7 minus 5. 2 times 7 is 14, minus 5 is 9. That is our answer. Bonus. Might need a full page for this bonus. Let's see if we can figure out what this bonus is. You can use the diagram there to make some notes. Looks like they have given us 3 triangles. I'm going to draw that picture. A reasonable facsimile of that picture. Use your imagination to understand that this is parallel to this. this one is parallel to this one. They have said this is 10 right there. All right, let's see all this information that we have. ABC, triangle ABC, has side lengths 5 to 2.5 to 4. Scale factor of ABC to DEC, DEC, this triangle right up here, is 5 to 2. So I'm going from that triangle to that triangle. I have a scale factor of 5 to 2. So if I have some length in this first one, I can figure out lengths in that second one. Scale factor of DEC to FEG is 1 to 4. So when I go this way, DEC to the other one, scale factor is 1 to 4. So if I started at the first ABC, I should be able to transfer it to the little DEC and then transfer that to the big last one, FEG. BC is the shortest side, so 10 here is our shortest side in the first triangle. AB is the longest side. So AB, that's the longest side. We're supposed to find F2G. F2G over here. This is the one we are trying to figure out. What is that? Okay. Well, if we look, figure out where our congruent, if I go to this bottom triangle and that little triangle there, those are congruent angles. And I've got some parallel lines here and here. Those are alternate interior. Better do 2. Alternate interior. So it looks like that DE, I'm going to call it Y for a minute. That is going to be the side. Let's see if that one matches up with right over here, doesn't it? We're trying to find F to G. Let's see. So what other things do we have for congruent triangles? We also know that I'm just going to change colors. Those right there, vertical angles are congruent. I've got some parallel, one parallel. I'm going to go blue right there and blue down here. Those are alternate interior for the one marked parallel. These parallel. Those parallel sides, those blue. So, looks like this check mark down here in the first triangle, this check mark down here, that one goes to what I called Y in the middle, which is what I call the Y. And then that Y that I called in the middle goes with this check mark up here. It's not where we're trying to get, is it? Let's get to this X. The X is what we're trying to get. And that X goes with this X in the little one, which goes with this X and that big one. There, I think those X's all go together. They're all between the angle marks that I made. Now, I did it wrong. Good thing this is a bonus. Far right triangle, far right triangle. There's my 2 angle marks. I'm next to the 2 angle. So here are my 2 angle marks. I'm next to the 2 angle. I'm good there. Here are my 2 angle marks. I'm next to the 2 angle. There it is. That X belongs right over here. That's the one. Let me double check, make sure I'm getting the right thing. Okay, let me walk it through this way, see if we can explain it. Starting in this far right triangle, right over here. If I look at my blue angle marks, I have a 1 angle mark and I have a 2 angle mark here. And across from the 1 blue angle mark is the x that we are trying to figure out. So now I'm going to go to this tiny little triangle using those blue angles because that corresponds those top right two together. So I have a 1 angle mark and I have a 2 angle mark. And it was across from the 1 angle mark that I'm looking for. So far so good. So those x's go together. And if I do the little triangle in the middle to this big one down here, it's the red marks that correspond. Let me make those back red. I have a 2 and a 1 angle mark. I have a 2 and a 1 angle mark. And it's between the 2 and the 1 angle mark in red. So between the 2 and the 1 angle mark in red, I had it right earlier in the first one, in red, that's the one I want, not the one down here, not the one up there. So there are the x's that I want to try to go between. So let's see if we can figure out that x in the first triangle. Now they have told us in this first triangle we have a ratio of sides of 5 to 2.5 to 4. And the longest side was AB, that would be the 5x. And our 2.5, the shortest, that would be this one, the 2x. And then the 2.5x, that's the shortest. And then the 4 over here. So I know side 10. I can figure out this missing side in the first triangle. I'm going to use that 2.5x equals 10. 2.5 times some scale factor must give me the 10. So if I divide by 2.5, I get 4. So I know my x is 4. So now I can figure out what this question mark side is, since my x is 4. 4 times 4 is 16. This side must be 16. And that side, 16, corresponds to this x. And these triangles are in the ratio of 5 to 2. So I'm going to do that next, 5 to 2. 5 to 2 is the big triangle to the small triangle. That must equal 16 to that x in the small triangle. Cross products. 5x must equal 2 times 16. Divide by our 5. So 32 divided by 5. 6.4. 6.4. That must be the x in the little triangle. 6.4. Now I want to go from the little triangle to the triangle on the right. And I know that ratio is 1 to 4. So 1 to 4 is going from the little triangle to the big one on the right. And the little triangle has a side of 6.4, and the big one is a new x. 1 times x, x equals 4 times 6.4. So the side that has been eluding us, 6.4 times 4, 25.6. 25.6. Bonus. We figured it out. Might have stumbled a little bit getting there, but we figured it out. All right, the teacher has additional work for you as needed. There are the notes. Make sure you have them ready to turn in on Monday, and any additional work to turn in on Monday, test over Chapter 7 on Monday. I'll see you then.